Alright, 10.1 to 10.3. This is the concept of inheritance. Alright, very kind of go hand in hand with polymorphism. Pretty easy, although very important, particularly for the grid world case study. Any of the critter or bug classes that you'll be extending, which we kind of worked with a little bit already, this is the concept of inheritance. So inheritance is a mechanism for extending existing classes by adding methods and fields. So in a very general, everything is a subset of object. And then let's say we had a bank account class, which they are all subclasses. And let's say we wanted to make a savings account. Well, there's no reason to make... That was terrible. If a savings account is very similar to a bank account and only differs in a couple ways, there's no reason to rewrite the whole thing. So what I would have to do is just write the new stuff. See if this works. Get my board straight so I can write on it properly. So the more general class, that's what's called my super class. See if this starts to write. There we go. More general. Okay, and the more specialized class is what's called a subclass. Now you can have subclasses of subclasses that can chain out for quite a while. Yeah, so they're the more specialized one. And remember, every class extends object either directly or indirectly. The one thing about inheritance that's useful is the subclass, this automatically inherits everything. Inherits, gets all methods and fields of the superclass. So if I had a bank account, if I had a savings account, which is a subclass of the bank account superclass, it already gets withdrawal, it already gets deposit, it already gets the balance field, all those things you already wrote. You don't have to write them again. All you have to write is what is different. Okay. So this, just to clarify, so on page 440, inheriting from a class differs from implementing an interface. Okay, an interface is not a class. You don't ever make a new interface. Okay, you don't ever instantiate one. An interface has no state and no behavior, whereas a superclass or a subclass the superclass has a state and behavior, and the subclasses inherit them. One important reason for inheritance is code reuse. By inheriting an existing class, you don't have to replicate everything. So let's do a savings account, and let's see how it would be different from the bank account. So it's going to look very much the same. So public class savings account. Now, this is what's going to be a little different. Extends. I'm running out of room. Bank account. Okay. So that's the keyword extends, tells the computer that this is a subclass. And then, again, we only have to write the new stuff. And we do have to give it a constructor. And we'll go over the specifics of that later. So public savings account. Okay, and do be careful. It is the constructor gets the subclass name. All right. All right. We're not going to say anything about bank accounts here. Okay. So public savings account. Now, do I want some parameters? In this case, we're going to have a savings account which has an interest method because savings accounts generally give you some sort of interest. So we'll have a double rate field in our constructor, and then we're out of room. We'll fit it in somewhere else. And new instance field, interest rate equals my rate parameter. And then let's only have one method. public void add interest. Okay, no parameter. Now this is a little weird. We're going to do this. We're going to, again, we could do this all one step, but we'll write it out a little bit more so we can talk about it. Oops. Got ahead of myself here. Double interest, and then I will deposit that double amount of interest, and then have down here, because I forgot to write it at the top, private double interest rate instance field. So that is my savings account class. It only has one constructor and one method, but notice what's a little weird. So notice that add interest calls the get balance, okay, and the deposit methods of the bank account class. All right. The reason being is because of encapsulation. Remember, we have the instance fields are private, and they can only be accessed by members of that particular class. Otherwise, you have to go through the methods, the public interface methods of that class to access the private instance fields. So while savings account inherits a balance field from the bank account class, it does not get to touch it directly. So you have to use the get balance method and deposit methods, or essentially you have to use the methods of the bank account class to do your work. So it's a little weird, but that's what you have to do. Okay. So that is 10.1. 10.2, page 443, inheritance hierarchies. Alright, sets of classes can form complex inheritance hierarchies. In Java, it is equally common to express group classes in complex, what they call complex inheritance hierarchies. If you look at figure 4 on page 444, we have this JComponent superclass, and we have JPanel, JText component, JLabel, and abstract button as subclasses. And then further to that, there's JText field is a subclass of JText component. And if you notice, JRadio button is a subclass of JToggle button, which is a subclass of the abstract button, which is a subclass of the JComponent class. Okay, so consider a bank that offers its customers the following account types. A checking account has no interest. It gives you a small number of free transactions, and a savings account that earns compound interest that compounds monthly. If we were to look at page 445, figure 5, you'd see the inheritance hierarchy for that idea. So the sort of a generic bank account class that does withdrawals and deposits and stores a balance, and then more specialized savings account and checking account classes, which have unique behavior under the sort of general heading of being a bank account. So the idea being, write a generic class, and then when you want to write something different, all you have to do is write the new stuff, or what's different, and that saves you some code writing. Alright, 10.3, inheriting instance fields and the methods. So we just kind of showed you that. So when you form a subclass of a given class, you specify additional instance fields and methods. Yeah, okay, so if you're going to have a subclass, you're only going to specify the new instance fields and any new methods that go with it. Okay, so because obviously you inherit all the other stuff. So there are two options that we have. One, you can override existing methods. If it doesn't make sense to write a new term, but you need to have something with should have the same name, but do something a little bit different. Two, you can inherit superclass methods without changing them and use them directly. Okay. Or three, define new methods. Alright, Now that is for methods only, okay? Instance fields are a little bit different. Okay, two options for instance fields, okay? So one, subclass inherits all fields. Okay, the trick being that you can never, first off, you can never override an instance field. So you inherit all the fields from your superclass. All instance fields in superclass are inherited. However, you can't touch them directly. Okay, and then any new instance fields for the subclass are present only present in subclass. So you have to be careful. If I if I'm going to use polymorphism, say, to make an array list of bank account object types, and I'm going to put, let's say, checking account and savings account in them, the computer will happily do it because they are subclasses. But I have to be very careful that I don't, you can't access subclass fields from a bank account. From the superclass, you have to be careful on how you call and cast and that sort of thing when you're doing that. Yeah. Now, one thing you do have to remember is that subclass has no direct access to the private fields, private instance fields of the superclass. You have to use the methods to get there. You have to use getBalance, you have to use deposit, etc. Okay? Now, the trick is you don't have to specify the implicit parameter, you just have to write the name. So, for instance, if we wanted to deposit some amount inside, let's say we had, if you look at the bottom of page 447, the checking account. Inside of the checking account, if it is a subclass, so it's checking account extends bank account, I don't have to worry about a specific parameter. I can just call, if I call deposit, so let's say with some amount, it's going to call the superclass deposit method. I don't have to do anything special. Okay. Now, the problem is, if we haven't overridden anything, this is okay. However, if there is no deposit method, we have not overridden, so if we haven't done this part, where we've overridden an existing method, then this works. I can do this. It's just going to go find the superclass one. If, however, inside of the checking account, let's say we had done this, let's say we're going to limit the number of free transactions you can do, and then I would do something like okay, now I have a problem. Okay, I got a big problem. Because now that I've overridden the deposit method, up here there's only one deposit choice, so it goes and finds the one in bank account. But as soon as I write a deposit method inside of checking account, alright, when you call deposit, and then it's going to do the whole this deposit, and what it does is it comes back up here and runs this deposit method again. Well, this deposit method comes in and calls the deposit method again. So back it goes. And this is a recursive call, which are very useful for some things, but in this case, it never stops. And it's going to run till the computer runs out of available memory and it kills everything. Your computer will lock. Or if the operating system catches it, it'll crash the program for you. Alright, so that, gotta be careful. If you've overridden a method, then you can't just call your superclass method. Okay? So, if I was going to do this, having written a deposit method inside of checking account, to avoid an infinite recursion, I have to use the keyword. So we can still do our transaction count, that's fine. It's a local instance field. And then I would have to use, actually, I think BlueJ puts it in blue, so we'll put it in blue. Because there's no reason in calling the deposit method. In fact, you can't directly access the balance field anyway. But you have to use the keyword super, and you would call the superclass deposit method. That way the compiler knows where to go. So then instead of calling this current deposit method, it'll back up to the superclass and find that deposit method and run that. Now, if there isn't an overridden one, again, then you don't have to use the keyword super. Okay. One thing you do have to be careful of, page 449, common error 10.2 is shadowing instance fields. Since a subclass has no access to the private fields of a superclass, alright, you don't want to put a similar instance field with the same name, so I wouldn't add a balance field, a private instance field called balance to my checking account, because then it's going to have two, but it's not going to work with the right one. Okay, so the get balance method, if I call get balance, it's going to pull a superclass one. If I call change like balance equals balance plus amount on top of page 450, it's going to update the other one. So that's what's called shadowing. You don't want to do that. Okay, again, also common error 10.3, failing to invoke the superclass method. If I have overridden, done an override on an existing superclass method, and I want to access that superclass method, if I just call it without the keyword super on it, okay, if I don't call super.deposit, I just call deposit, I end up in an infinite recursion loop, and that is a very bad thing. So be very, very careful with that.